In this video, we are going to graph linear equations. Let's begin. So how do we graph from an equation? Equations are often written in slope-intercept form, or the form of y equals mx plus b, where the m represents the slope and the b represents the y-intercept. Now, notice in this form, the y is on the left side of the equal sign. It's by itself. Now, does it really matter that it's on the left side of the equal sign? Not necessarily, but that it's by itself on this side of the equal sign, right? So if I drew a wall down the middle of the equal sign, it's over here by itself. There's no x, there's no constant. It's not 2y, it's just y by itself. All right? So that's slope-intercept form. Explain in your own words how to draw a graph from an equation written in slope-intercept form. Well, we already know how to do that. You take the slope, or I say you take the y-intercept, or you put a point at the y-intercept. Then you use the slope to plot your next point. Using rise over run. Rise over run. Now, that's why it's actually nifty for your slope to be in a fraction form and not a decimal form. Anyways, let's continue. Solutions and equations. Solutions to linear equations include any points located on the graph line. So an equation like, y equals 2x plus 5 has lots of solutions. What are the different solutions? Well, it's all the x and y ordered pairs that, will make that equation true. Additionally, an ordered pair is a solution to an equation if its values are substituted in the equation and it makes the equation true. Yeah, that's what we just said. That looks like a U. There we go. Practice graphing equations and identify the solutions by using the graph below. Graph y equals 1/2 x. Let's do 3 different colored lines. It's going to be line A. Line B is going to be blue. And line C is going to be green. So let's graph these 3. My slope is 1/2. My y-intercept is 0. There is none, so it's 0. Let's just start with that. You start at 0, and 1, rise over run, rise 1, run 2. Rise 1, run 2, rise 1, run 2, rise 1, run 2. And you want to apply that pattern backwards, so rise -1, run backwards 2. So you do it backwards as well, and then you get this line, which is pretty good line, yeah. And they want me to call it line A. Let's do line B. Our slope is like -1x. So that is a rise and run of -1 over 1. Our y-intercept is +3. So we start at 3. Rise over run of -1 over 1. So down 1 over 1. Down 1 over 1. Down 1 over 1. Here we go. All these points. Let's see if I can get a straight looking line. Fairly straight. They want us to call this line B. And then line C is y equals -3. What is my slope? Well, remember, slope is whatever's being multiplied with x, and there is none, so it's going to be 0. And remember, a slope of 0 is a flat horizontal line. My b, or y-intercept, is -3. So we start at -3, and then it's just a flat line that goes straight across like that. All right, let's answer some questions. Is 6,3 a solution to, we didn't write C for our third line. Is 6,3 a solution to the equation in A? How do you know? All right, 6,3. Is there a point at 6,3? Let's see, 6,3. Yeah. 6,3 is over here. Yes, it is. Yes. How do I know? It's on the line. It's on line A. Is 10 -7 a solution to the equation in B. How do I know? 10, negative 7. Where is 10, negative 7? 10 over here, I guess 7. This would be 8. This would be 9. This would be like 10, I guess. Negative 7 would be like down there. Gosh. Do I know? Let's see. If I kept going down, this would be like, this is 8. This point right here is like 8, negative 5. It'd go like 9, negative 6. 10, negative 7. Yes. How do I know? If I extended the line. If I extend the line, it will run through 10, negative 7. That's a tough one. Number 6, give a solution to the equation in C that you can see from the graph. Oh, line C. How about this point right here? 2, 3. 2, 3. So that looks 2, 3. You can also do like, 3, 3. So 2 3s right here, 3, 3, 4, 3, 0, 3, negative 2, 3. All of those would work as solutions to our to line C. Now, they want us to give a solution to the equation in A that we cannot see on the graph. So if we extended the line on A, remember it's rise 1, run 2. So this last point right here, that is 0.4, no, not 0.4, 0.84. The x value is 8, the y value is 4. If I rise, and if it's a rise 1, run 2, if I rise 1, run 2, rise, the y goes up by 1, goes up to 5, and run 2, that would go to 10. So our next point would be 10, 5. If I rise 1 more and run 2 more, that'd be like 6 and 12 and 7 and 14. And I could also take that one backwards if I wanted to. So that does not look like an end parentheses. There it goes. Number 8. Charlotte is given the equation 3x minus 4y equals 12. She needs to create a graph of the equation, but isn't sure how since she is only familiar with graphing from slope-intercept form. Devise a plan to help Charlotte graph the equation in the space below and then draw your graph line. Well, she needs to just solve for y, get that y by itself. So what I'm going to do is I'm going to rewrite the equation 3x minus 4y equals 12. And we need to get this y right here by itself. So let's get rid of the 3x first. That'll cancel. Subtract 3x from both sides. Remember, they are not like terms, so I cannot combine 3x, negative 3x right here, and this positive 12. So I'm going to write negative 3x plus 12, because that 12 is positive, right? There's an invisible positive sign in front of it. Bring down the negative 4y, because it's not just 4y, it's negative 4y. Now, I still need to get the y by itself, so get rid of the negative 4 by dividing by negative 4. That'll cancel that out and leave me with y. If I divide that by 4, I divide this by negative 4 and divide that by negative 4. Negative 3 divided by negative 4. Negative divided by negative is going to be a positive. You're going to leave it in fraction form, 3/4 x. Positive 12 divided by negative 4 is going to leave you with a negative 3. So we now have an equation written in slope-intercept form. Now let's graph that. Our slope is 3 over 4. Our y-intercept is negative 3. So we start at negative 3. A slope of 3 over 4 means rise 3, run 4. Rise 3, run 4. 1, 2, 3, up. Did not run 4. There we go. Rise 3, 1, 2, 3, 1, 2, 3, 4. There we go. And then go backwards. 1, 3, 1, 2, 3, 4. And then that's all I can do. The next point would be like down there or something like that. So, oops. Something like that. That's what that would look like. All right, we have 3 lines, 9, 10, 11. Let's go ahead and color those. I'm going to make the first one, line F. Let's make that in green. Let's make line E in blue. And let's make our first line, line D, red. Let's do some practice. Let's graph graph these lines. Now I have to convert these into slope-intercept form, so subtract 3x from both sides. That'll cancel. That leaves me with negative 9y equals negative 3x plus 18. Divide by negative 9, which will cancel out the negative 9s. You're left with y. Negative 3 divided by negative 9 is positive. What is it? 3 over 9. 3 over 9. Can we reduce that fraction? We can. That's just 1 over 3. And it's positive x, because negative divided by negative is positive. 18 divided by negative 9 is going to be a negative. It's going to be negative 2. It's going to be our equation. Let's go ahead and do our next equation. Actually, let's go ahead and graph while we're at it. Slope is 1/3. Y-intercept is negative 2. So, start at negative 2. Slope of 1 over 3, rise 1, run 3. Rise 1, run 3. Rise 1, up, can't do it. Rise 1, run 3, backwards. Run 3. All right, there we go. So, something like this, I guess. They want us to call it line D. Let's do line E now, also not in slope-intercept form. So let's get rid of the 6x. 9 and 6x do not combine, so I'm left with negative 6x plus 9. We have 3y over here. Divide by 3 to cancel. We're left with y. Divide this by 3, divide this by 3. Negative 6 divided by 3 is negative 2x. 9 divided by 3 is 3. Our slope is negative 2, or negative 2 over 1. Our y-intercept is 3. So let's start at 3. And rise over run. Rise negative 2, 1, 2. Run positive 1. So negative rise. Down 2, run 1. Rise 2, run 1. Nope. Okay, go backwards with that as well. Okay. Let's draw a line through all these things. It's a really junky line. I'm sorry about that. That is line E. And then let's do line F, which we also have to convert. All right. Into slope-intercept form. Subtract 4x from both sides. That'll cancel. Subtract 4x from over here. You are left with not just 2y, but negative 2y. Equals negative 4x plus 8. Divide by negative 2, which cancels the negative 2's. Divide this by negative 2, divide that by negative 2. Negative 4 divided by negative 2 is positive 2x. 8 divided by negative 2 is negative something. It is negative 4. So our slope is 2. Our y-intercept is negative 4. Start at negative 4. Slope of 2 is 2 over 1, right? So rise 2, run 1. Rise 2, run 1. Rise 2, run 1. 2 over 1, 2 over 1, 2 over 1. And they call this line F. All right. Which line above has a solution of 2, 0? How do you know? Well, let's look for solution 2, 0. 2, 0. 2 is x, 0 is the y. So right 2. Oh, right there. That's 2. That's line F. Because line F runs through it. Runs through it. Which line above has a solution of 15, 3? And how do you know? 15 and 3. 15 and 3. Uh-oh. 15 and 3. This goes up to 8, 9, 10, 11, 12, 15 and 3. And it goes up a little bit to 3. Which of these looks like it would go to 3, 15, 3? It looks like the only reasonable answer is D. How do you know? It's the closest line. It's the closest line. Now, how can we prove it? Actually, we can prove it through substitution. If we go to line D and we substitute the numbers 15 for x and 3 for y, we can see if it's true. Because line D, let's check actually. Line D is 3x minus 9y equals 18. And we said, remember, x is 15, so replace 3 with 15, x with 15, so 3 times 15 minus 9y, so 9 times 3 equals 18. What is that? 45 minus 9 times 3 is 27 equals 18. Does 45 minus 27 equal 18? That is off the top of my head. I have no idea. Let's go ahead and calculator that. 45 minus 27. Yes, it does. So that's another way you can check, is just substitute the numbers into each equation and see if it makes a true statement. All right, 14, list two solutions to line E. Line E is the blue one, including one that cannot be seen on the graph. All right, let's try one solution to line E. How about this one right here? That's 3 and negative 3. That is 3 and negative 3. And one that cannot be seen on the graph, well, if I kept going down, remember this is a rise of negative 2, run 1, rise negative 2, run 1. So I'm at negative 7. This point right here is 5. The x is 5 right here. The y is negative 7. So if I go down by 2, and I go run 1, go right to the by 1, that means that would turn into negative 7, would turn into negative 9, and 5 would turn into 6. So 6, negative 9 is 1. That would be off the grid. And that's it. That is how you graph using graph linear equations, whether they are in slope-intercept form, like our first couple of examples, or whether they're not in slope-intercept form, and you have to rewrite them in slope-intercept form and then graph them. All right, go ahead and try some problems on your own.